This is the video for section 16-2, day 1, on solving exponential and log equations. Key vocabulary in this lesson will be exponential equation and log equation. And at the end of these 2 days, you should know how to solve exponential and log equations. So to start off with, an exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, first thing you're going to try and do is to write them with the same bases, because if they have the same base, then the exponents have to be equal. Or try taking the log of both sides, because if a equals b, then the log of one has to equal the log of the other. Then the definition of a logarithmic equation is an equation with a log expression that contains a variable. And you can solve log equations by using properties of logarithms. So if the log base b of x equals log base b of y, then I know that x has to be y. The key thing here is that the logs have to have the same base. So what does all this mean? Let's look at some examples. So on example 1, we have 7 to the x equals 7 to the 2x minus 3. So if we remember on the exponential vocab, if we go back one right here, it says if they have the same base, then I can just set the exponents equal to one another. So if we look at example 1, 7 and 7 are the same, so I really just have the exponents that I have to work with in order to solve for x. So then the opposite of adding 2x would be subtracting, and then divide by -1, and we get that x equals 3. On example 2, they are not the same base. So what we want to do is we want to try and come up with a number that I can write 125 with a base raised to a power, and 5 of that same base to a power, 25 to that base with the same power. And if you think about 125 and 25, they both have a common base of 5, because I know that 125 is 5 to the third, and I know that 25 is 5 squared. So I can really rewrite this as 5 to the third to the x equals 5 squared to the x plus 1. Then I'm going to distribute, because a power to a power you multiply. So that's really 5 to the 3x equals 5 to the 2x plus 2. And now, since they both have a common base of 5, I just have to solve the exponents. And I get that x equals 2. Pause the video and give example 3 a try. Example 3 should end up with x equals 2 because of the fact that they both already have the common base of 8. You just have that 5x has to equal 3x plus 4, so subtract 3x and then divide by 2, and you should get that x equals 2. Example 4 is a little different, so let's work this one together. If I look at this, the base is 4 on the left side and the base is 1/2 on the right side. So we kind of have to ask ourselves, what is a number that both of these can be raised to a different exponent, but it's still the same base? And if I think about it, 4 is really 2 squared, and 1/2 is really 2 to the negative first. So if you have a fraction, that exponent's probably going to be a negative. So I'm going to rewrite this as 2 squared to the x equals 2 to the -1 to the x minus 3. Multiply, so that's going to give me 2 to the 2x equals 2 to the -x plus 3. Now I can just solve the exponents. So that's going to give me 3x equals 3, so x equals 1. Example 5, you notice we have a different type of base here, but if we're solving, kind of think of it this way. What's the opposite of multiplying? Because you really have multiplication going on in front here, right? So the opposite of multiplying would be dividing. So if you divide both sides by 4, you're left with e raised to the 3x minus 5 equals 18. And then if we think about this, we can use our property of logs that we've been studying, and it's an exponential form, and I'm stuck, so I can convert this to log. And remember that when we have log base e, that's really the natural log. So I can say the natural log of 18 equals my exponent. So then the opposite of subtracting is adding. So I have the natural log of 18 plus 5 equals 3x. And the opposite of multiplication is division. So then my answer in my calculator, I'm going to type the natural log of 18 plus 5, get that, and then divide by 3. And you should get roughly 2.63. Example 6 is similar, but if you notice now we have an addition here, which means we got to work with it first. So I'm going to subtract 8 first. And now this problem looks just like example 5. So pause the video and see if you can work it from here. Okay, so on example 6, your final answer should come out to be 2.77. How did we get there? The opposite of multiplying is dividing, so 12 divided by 6 is 2. Then I converted this to log, and remember that log base e is really natural log. So the natural log of 2 equals your exponent of 0.25x. The opposite of multiplying is dividing, so then I just divided both sides by 0.25, and I typed this in my calculator in order to get 2.77. For the rest of the problems, for examples 7 through 10, it's solving log equations. And if you notice in the directions now, it says to check your answers. That's because you cannot take the log of a negative number or a 0. So you have to make sure that when you plug in your x value, that in the original problem you're not getting a negative or a 0 within the log. So on example 7, we have log base 6 of 2x minus 1 equals negative 1. Now, this is in log form, and I'm stuck. So the easiest way to solve it would be to convert it to exponential. So our base of our log would be the base of the exponent, which is 6. What it's equal to is the exponent, so negative 1, equals what you're taking the log of. 6 to the negative 1 is really 1 over 6. Add 1 to both sides. And divide by 2. Now, if I check it, 2 times 7 over 12 minus 1 has to be greater than 0. Not equal to 0, greater than 0. So if I check that in my calculator, if 14 over 12 minus 1, is that greater than 0? And the answer is yes. So this is a valid answer. On example 8, if we think about our log properties, subtraction really means that we're dividing, so I can rewrite this as log base 4 of 100 divided by x plus 1 equals 1. Now I have a single log equals, so I can convert it to exponential. So 4 to the first equals 100 over x plus 1, which is really just 4 equals 100 over x plus 1. Opposite of dividing is multiplying, but you've got to remember that when you multiply, you have to distribute on this side. So that's really 4x plus 4 equals, those are going to cancel, 100. So 4x equals 96, and divide by 4 and you get that 24 equals x. Again, if I go back and check, there's not an x in this part, but 24 plus 1 would be the log of 25, which is greater than 0, so then this is my answer. Pause the video, give example 9 a try for yourself. Remember that with logs, addition is the same thing as multiplying, so that's probably where you want to start. Okay, so if we start with the multiplying, you should end up with x times x plus 1 inside the log, which foiling the x or distributing the x in, you get x squared plus x. Then it's in log form and I'm stuck, and it's a single log on the left side here. So I'm going to convert to exponential, so that would be 12 to the first equals x squared plus x. 12 to the first is just 12. And then because I have an x squared and an x, I have to get it all equal to 0 so that I can factor or use quadratic formula. So in this case, I end up with x squared plus x minus 12, which does factor to x plus 4 and x minus 3, which tells me x equals negative 4 and x equals 3. However, when I go back and I check right here, if I plug in a negative 4, you cannot take the log of a negative number, so that does not work. I don't even have to check the other one. If I plug in a 3, that's still good, and 3 plus 1 would be 4, which is a positive, so that's still good, so then 3 does work. So negative 4 would be our extraneous solution, meaning that it works when we solve, but when we plug it back in, it does not work. So really the only answer to this problem is x equals 3. Example 10 is along the same lines, but it looks a little different, so let's work this one together. Again, you're not going to do anything until you have the single log by itself. So what I'm going to do first, the opposite of addition is subtraction. So that's really 2 natural log of x equals negative 1. Then, if you remember, there's 2 things you can do from here, and I'm going to work it 2 different ways in just a second. First way is the opposite of multiplying is dividing, so you could say the natural log of x equals negative 1/2. And then here, this is in log form, and I'm stuck, so I can convert to exponential. Remember, this is really log base e, so that means it's going to be e to the negative 1/2 equals x. Remember to type that in parentheses when you type it in your calculator, and you will get 0.61. The other way of doing it is from this point, after you move the 2 over. If you remember, your property says that the number out front is really the exponent, so you could then say, okay, well, that's really the natural log of x squared equals negative 1. So then you have that e to the negative first equals x squared. So then take the square root of both sides, and then type that in your calculator, and you'll still get the same answer. Personally, I think this is the easier method.